Hey, welcome everybody. This is Mr. Gannon, and we're going to do the 11.2 notes where we're going to learn how to graph logarithmic equations. So we're going to start out actually with something we did in chapter 10, and we're going to make a table and we're going to graph the exponential function y equals 2 to the power x. So, just kind of going back to that table of values, we're going to go x, y. We're going to use -2, -1, 0, 1, and 2. When we did this with exponentials, I had to start with 0. So 2 to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. And then for negative exponents, just a reminder, when the exponent's positive, I think about multiplying by the base. When the exponent's negative, I think about I'm dividing by the base that many times. So if it's -1, that's going to be 1 divided by 2. If the exponent's -2, then it's going to be 1 divided by 2 times 2, which is 4. All right, so those are points that would help us graph y equals 2 to the power x. So if we look at the graph, if we start with 0, 1, we get this point. 1, 2 means right 1 up 2. 2, 4 is right 2 up 4. And then -1, 1/2. We're going to go left 1 up half. -2, 1/4 is left 2 up 1/4. All right, and the graph's going to curve up to the right, and then it's going to come down towards the x-axis on the left, but it never actually gets there. So just kind of a reminder, there's that horizontal asymptote when we're dealing with exponential functions. All right. If we look at the function, the next question talks about domain and range. So domain in this example is simply all real numbers because our graph will go left and right forever. The range, however, is going to be y is greater than 0 because our graph will never cross that horizontal asymptote. It's always above it. All right. Now, part B here says, because we're not graphing exponential functions, it says switch the input and output values, so the x and y's, and graph them on the same grid. All right, so let's do that in green just so it kind of stands out. So if we switch x and y, the x values are now going to become our y values, and our y values are going to become our x values. All right, so we're simply switching those values. Now, if we graph those points, all right, we're going to have the point 1, 0. So we're going to go right 1 and put a point. 2, 1 is right 2 up 1. 4, 2 is right 1, 2, 3, 4 up 2. And then for these other points, you've got 1/2 -1, which is here. 1/4 -2, which is here. All right, so what's going to happen is this graph is going to curve up to the right like this, and then on the left side, it's going to come down and approach the y-axis, but never get there. So like this, the exponential had a horizontal asymptote. This function is going to have a vertical asymptote. All right, now it says, what are you graphing? Well, if we can think back to, I believe it was chapter 8, what switches x and y values are the inverse. So in this case, we are like when it says, what are you graphing? All right, we are graphing the inverse of y equals 2 to the power x. Okay, and if you think back to what we talked about before, the inverse of exponentials are logarithms if they have the same base. All right, so for here, though, let's just kind of talk about the rest of this. So the domain here are the x values, which were the y values. So up here, what happens when you switch x and y is you're really switching the domain and the range. So now the domain of our new function will be x is greater than 0, and the range will become all real numbers. Because if we look at the graph that's green, it's going to go down forever and up forever, but it never goes past the y-axis. It never goes left of the y-axis, I should say. All right. Now, over here, it says fill in the table and graph y equals log base 2 of x. So this one for some people is going to be a little hard to kind of conceptualize at this point, but we're plugging in x values. So, when you plug in 1/4, the y value is going to be log base 2 of 1/4, log base 2 of 1/2, log base 2 of 1, log base 2 of 2, and log base 2 of 4. Now, the way I think of logarithms are exponents. So when I see an expression like this, I'm thinking, let's just start right here with the log base 2 of 1. I'm thinking, what power of 2 is 1? Okay, that's what I'm thinking in my head. And the only way to take a number to a power and get 1 is for that exponent or that power to be 0. So that's going to be 0. And then when I look at log base 2 of 2, I'm thinking, what power of 2 is 2? Well, that's the first power. What power of 2 is 4? That's the second power. Well, what power of 2 is 1/2? Well, this time I'm taking 1 and dividing by 2, so I know my exponent needs to be negative. It's going to be -1. And what power of 2 is 1/4? Well, now we need to be dividing by 2 squared, so my power is -2. All right. Well, if you notice, this table that we just completed here is identical to this table here. Okay. So when we think about this, y equals 2 to the power x and y equals log base 2 of x, they are inverse functions or inverses. All right, so in that example, we basically looked at how we can graph a logarithm using the exponential function that is its inverse. But we want to get to the point where we can graph these functions without having to graph the exponential first. So, transformations. The transformations are going to be the same as they've always been. So here's what the HK form of a logarithmic function looks like. Just kind of a quick review. The a value. If a is greater than 1, we have a stretch. And it's a stretch by a. If a is greater than 0 but less than 1, it's compressed by a. For the h value, if it's x minus h, the graph is going to move to the right h. If it's x plus h, the graph's going to move to the left h. For the k value, when it's plus k, the graph will move up k units. And if it's minus k, the graph moves down k units. The only other thing that can happen is we could have that negative in front. So kind of sometimes people think about it as that negative a value. That's going to cause a reflection. And specifically, it is a vertical reflection. All right, so we should, when we see one of these equations, we should be able to identify those transformations. It says, hint, identify transformations first. That's the same thing as making sure you can identify a, b, h, and k, So I'm going to make a little note here. So, on top of that, we want to identify a, b, h, and k. Now, from there, all right, kind of going back to this graph up here, when we graphed exponential functions, there was always a horizontal asymptote. Well, since logs are the inverses and we are switching x and y, that horizontal asymptote now becomes a vertical asymptote. So our log functions are always going to have a vertical asymptote, and that's really where we're going to start. So for me, step one of graphing is we're going to graph the vertical asymptote, so VA, and that's always going to happen at x equals h. So that's one of the reasons why we want to identify those transformations is so that we can graph the asymptote, okay? So vertical lines are going to move left and right. Step two, all right? Now, there's always going to be an anchor point with these parent functions. And up here, the anchor point happens at the x-intercept. It's 1, 0. So for step 2, what we're going to do is we're going to move that point 1, 0 using h and k. Okay, and we'll talk about what that looks like here in a minute. So we're going to move 1, 0 using h and k. All right, that is what is referred to as the anchor point. So if your teacher talks about that, that's what they're referring to as that initial point. And the reason we only use h and k is that it has a y value of 0, which means stretching the graph will not affect the location of that point. Because if I multiply 0 by 5, it's still 0. All right, the third part of this, we're going to basically go back to the vertical asymptote. Okay, so we're going to go back to the VA, kind of like we did with exponentials. We're going to go back to the VA, and then you're going to go up, or it could be down, the A value. So go up or down A, and right B. So whatever the base is, that's how far you're going to go to the right from the asymptote once you go up or down the A value. So those are the steps. We got the vertical asymptote. We're going to move the point 1, 0, left, right, up, and down using h and k. We're going to go back to the vertical asymptote, and we're going to go either up or down, and then right the base. So up or down A, right the base. All right, so if we take a look here, I'm going to kind of go through this kind of following all these steps. So if we start, I'm going to find A, B, H, and K, just so we make that a habit. Base is 2, that means A is 1. H will be -3, K is -1. So in terms of transformations, this graph is going to go left 3 and down 1. All right, so to graph it, we graph the asymptote. So we're going to go from 0, 0, we're going to go left 3, draw in that vertical line. Then we're going to start at 1, 0, always 1, 0. And we're going to go left 3, down 1. Okay, so left 3, down 1. We're going to go back to the asymptote. This time we're going to go up 1 because of A, and we're going to go right 2 because of the base. Our graph now curves up to the right, down on the left. Our domain, x is greater than -3, and our range, all real numbers. So just kind of a quick recap. We did the vertical asymptote first, which was left 3. We took the point 1, 0, and we moved it left 3, down 1. Those are the transformations. We went back to the asymptote. We went up A, which is 1, and right B, which was 2. And that's it. So, guys, I would recommend, pause the video, try to graph 2 on your own. All right. Now, what you should start with is A, B, H, and K. So this time we have a base of 3, we have an A value of 1, -2, +4. So again, with transformations, we're thinking left 2, up 4 in this case. All right. From there, we graph the asymptote. So from 0, 0, we're going to go left 2, draw in that vertical asymptote. Then we're going to move 1, 0. So we're going to put our pencil at 1, 0, and we're going to move left 2, up 4. Those were the transformations. We're going to go back to our asymptote. We're going to go up A, which is 1, and we're going to go right the base, which is 3. Curves up, comes down. All right, so again, we got our domain. In this case is going to be x is greater than -2, and the range, all real numbers. So it will really benefit you to take the time to learn these steps, okay? I mean, there's really 3 things that we're graphing. We're graphing a vertical asymptote, we're graphing the anchor point, and we're graphing 1 additional point. From there, we sketch the curve. All right, next one. All right, number 3, same thing, pause the video, try it on your own first. So we find A, B, H, and K. The base is 2, A is -1, H is 3, K is 0. So now, when you talk about transformations, we have an A value that's not 1. So if it's a negative, there's a reflection. All right, and then we have an H value of 3, which means right 3. So now, when we go to graph it, from 0, 0, we're going to go right 3, draw that vertical asymptote. Then we're going to take that point 1, 0, and we're going to move it right 3. That takes us here. All right, this time our A value is -1. So when we go back to the asymptote, we're going to go down 1, and then we're going to go right the base of 2. Graph's going to curve down on the right, curve up on the left. Domain, x is greater than 3, and our range is all real numbers. Okay. All right. Number 4. We got A, B, H, and K. This time the base is 2, A is 1, H is 0, and K is -2. All right, so when it comes to transformations, the only thing going on is down 2. So we're going to start by graphing our asymptote, which is 0. So we just draw in that dashed line. Then we're going to take our anchor point 1, 0, and we're going to move it down 2. Go back to the asymptote. We're going to go up A, which is 1, and right B, which is 2. Curving up on the right, coming down on the left. X is greater than 0 is the domain. All real numbers is the range. Yep. All right, we got a few more. So for number 5. All right, this one's a little different because now we're looking at natural log. So we're still going to find A, B, H, and K. All right, A is -1. Now the base here, when it's natural log, you've got to remember the base is E. And then the other part of E is that that's about 2.72. H is 0, K is 4. So when it comes to transformations, we have a reflection, and we're going up 4. All right, our asymptote is going to be at H, which is 0. We're going to move the anchor point 1, 0 up 4. We're going to go back to the asymptote. This time we're going to go down 1 because of A being -1, and we're going to go right E, or about 2.7. So we're just going to go right, a little less than 3. Graph will curve down on the right, go up towards the asymptote on the left. Our domain, x is greater than 0. The range, all real numbers. All right, next one. And now we're going to kind of look at what happens when there's a stretch. So again, we start with A, B, H, and K. A is 2, the base is 3, H is -1, K is -5. So from a transformation standpoint, we have a stretch by 2. We are left 1, down 5. So what that's going to look like graphing is we're going to start going left 1 for the asymptote. We are going to move that anchor point 1, 0, left 1, down 5. We're going to go back to the asymptote. This time we're going to go up A, which is 2, and we're going to go right B, which is 3. So when you go back to the asymptote, it's up 2, right 3. Graph will curve up, down. Domain, x is greater than -1. Range, all real numbers. All right, next. All right, number 7. Now we have A, as 1/3, we have B as 2, H -3, K -1. So we have a compression. So we're compressed by 1/3. We are left 3, down 1. So graph the asymptote. So from 0, 0, we're going to go left 3. We're going to move the anchor point, 1, 0, left 3, down 1. And then this one will be a little tricky, but when we go back to the asymptote, we're going to go up A, which is 1/3. So, 1/3 of the way to 0. And then we're going to go right our base, which is 2. So that point, it's not too far away. So we're going to kind of slowly curve up to the right and come down on the left. Our domain, x is greater than -3, and the range is all real numbers. All right, and finally, we got our last example here, number 8. So start with A, B, H, and K. Our A value, we're going to call -3. The base is 2. H is 4. K is 0. So from a transformation standpoint, we have a reflection because of the negative. We have a stretch by 3. And we are shifted right 4. So as we go to graph, from 0, 0, we're going to go right 4, draw in our asymptote. Then we're going to move the point 1, 0, right 4. So 1, 2, 3, 4. All right, when we go back to the asymptote, we're going to go down 3 because of the A value. So 1, 2, 3. And we're going to go right our base, which is 2. So what will happen is this graph will curve down on the right, and it'll come up on the left. The domain, x is greater than 4, and the range is all real numbers. All right. Hope you guys found the video helpful. If you have questions, make sure you see your teacher, ask those questions. But I would highly encourage you, spend some time making sure you understand and can follow those steps. All right, have a good day.